So yeah, let's get started. So thanks for coming. My name is Brock Allen. I have the privilege of working in security full-time, which, you know, that's a that's a subjective thing, I suppose. I basically help customers. I do consulting. I work for Soliance, which you may have seen them as a sponsor here in the conference. I help customers architect their identity and access control for their enterprise or their application architecture. That basically means I work a lot on things like user authentication, managing your database of username, passwords, two-factor auth, that kind of thing. I'm also helping with things like single sign-on, which is of course the very useful feature for applications, and also related to that is API security. I do consulting. I obviously speak at conferences, and I also work on several open source projects. Oops, excuse me. One of them is something called Identity Server. It's probably the most popular of these, which is basically a framework for helping you add single sign-on and API protection to your application architecture. So the point of this talk is to talk about these protocols called OpenID Connect and OAuth2. We're going to talk a little bit about the history of, kind of what we used to do for security and things like authentication and single sign-on. Those have been around a while. But OpenID Connect and OAuth2 are the sort of modern versions of those. So we're going to talk about the history, why these have been supplanted the old protocols. And what I'm going to do is kind of run through some of the scenarios to show you what it looks like from an applications perspective. So this talk is kind of a protocol talk, more to give you an idea of what the protocols are about and how they fit in. I do have a session later today from the server perspective, so the actual thing called a token server. So we will be demoing Identity Server and getting that set up. If you've never seen it before or interested in what's involved with the few steps of getting it set up, that's what the other session later today is about. So when I started doing security or even just programming, 20 some odd years ago, security was easy because what you would do is you were building, applications for employees in the enterprise. And the idea is that those employees would come in and use their, employer-issued ID card, come in through the door, walk into their cube, sit in their employee, the company-owned chair. They would sit at the company-owned computer, and they would log in with their company credentials. And then they would be in the ecosystem of the, enterprise using applications for employees to do their job. And so that all basically worked because applications in that context were designed to run in a single sort of trust barrier, if you will. And that was basically Active Directory. That's basically designed for employee types users and authenticating those users across all the applications within that enterprise. And from an application developer standpoint, it was really, really easy to just make this kind of work in your applications. Some of the things you would do is like just go into IIS and check that little checkbox called Integrated Windows Authentication, and things just kind of worked, and that's about all you had to do to think about security and get things working for the most part. Now, for employee types of users, that was pretty easy. It was always then for other types of applications where your users were more like customers. That type of application usually lived outside of that trust boundary, and that would be something like where this web application that you would build, you would have to have your own login screen with your own different database of username and passwords, and it was considered to be kind of a separate sort of model, if you will, for authentication, mainly because of the trust boundaries that were involved. So then that was great. We built apps for a while that way. And then a lot of times, your company would have a business partner, and that business partner would come to hey, my employees in the business partner, they want to use your applications, maybe the same type of application built for your employees. And so, it didn't really make a lot of sense, your business partner users to get set up in your Active Directory, as a user for them to just log in. Even sort of you could do that, I suppose, but then, of course, when they left the other company, no one ever calls you up on the phone and say, oh, by the way, we just fired Bob, or Bob moved on to another company. Can you deactivate Bob in your system? Right? The business partner would, of course, deactivate Bob in their system, but they never told you about deactivating Bob in your system. So we came up with some strategies for that called federation. And there were some security protocols that got used, and these are fairly, they've been around for quite a while. SAML2P and WS Federation were some security protocols to enable that for browser-based applications. And we had WS Trust and WS Security for more desktop-style applications that you were maybe using like SOAP services. Okay, that's all great. The similar motivation also came up in the consumer-facing applications that you might have been writing. And so this is the idea where your users don't want to have a new account with your system. They want to use their existing Facebook and Google-style logins to get into your app. Again, totally fine. You would build your app and figure out how to wire into that. But again, these fundamentally were kind of like two different worlds. So that was, things were running along just fine, and your enterprise apps were working for your employees and your business partner employees, and your consumer front end was working for those type of scenarios. And then this thing got introduced, okay? And this thing was basically shattered all of the assumptions that we had previously. I mean, if you look at the prior slide here, what made all this stuff work, at least in the enterprise, is we had this trust boundary. And we were relying upon everything, in this trust boundary, we were relying upon things provided by the operating system, like Windows and Active Directory and Kerberos, to make all of this trust work pretty seamlessly from your app's perspective. Well, what ended up happening was this thing got released, and Apple basically said, screw you to the enterprise. Right? I don't care about your SOAP services, and I don't care about your domain. Domain, what's that, right? We don't do domain joining. I'm not going to get that. I'm not going to give you that feature. And so that's basically, kind of like said, I don't care about how Windows does security. The problem is, of course, and so of course what they did adopt was, the whole modern style that we now see with, HTML and mainly, HTTP-based services, RESTful services. So the problem, of course, is your CEO goes out and buys one of these, right? And then they're like, oh, why can't I get our financial reports, the app we spent $2 million building, how come I can't see that on my iPhone, okay? Well, again, there's a problem there. So this really revolutionized how we build our apps. It forced our hand in building apps that could no longer rely upon the operating system level security features for authentication of our users. So what we had to do, and we were forced to come up with a new scheme, but at a higher abstraction level up the sort of dependency chain. And given that we basically now, when we're building applications, can pretty much only rely upon HTTP, that's basically the modern solution for this problem. So here's what our modern application architecture basically looks like. We're building lots of types of applications now. We're building, server-side web applications. This might be like your MVC, ASP.NET, even a Java server-side JSP type of application. We're building SPA applications, JavaScript heavy, all running in the browser, single-page applications. Of course, we're building native and mobile applications. Of course, your iPhone, iOS, Android apps. But this could also be desktop, your WPF types of apps. And basically, the user is going to be using one of these three types of front ends. So we want to authenticate the user to these. And then, of course, these things want to invoke APIs on behalf of the user. Okay? And all of that for the modern style application is all done over HTTP. So what we want to do is authenticate our users to our applications, and then when they invoke those APIs, we want to convey that identity across that network hop. The thing about this picture to kind of think about is, given that this is kind of the modern picture, everywhere there's an arrow, that's a network hop, and that's where we need to secure that call in one way, right? We need to know who that caller is, and we need to do it in a secure, trustworthy way. We also have a lot of scenarios, just the extra thing up here is we also have a lot of scenarios where you have some server that's running that wakes up every hour or every evening and then needs to go and do some work. Overnight's kind of a typical thing. And that also might need to invoke this API. A little bit different scenario, though, for that server-side thing. There is no human. There's no user involved. So when you invoke that API, it's really on behalf of an application-style account rather than a user-style account. So these are the kinds of things that we need to design for and enable in our security architecture. So for authentication, well, actually, let me take a step back. So then the thing you don't want to do is reinvent security at one of those, nodes, if you will. You don't want each web API to like do their own type of username and password. Oh, and this other app wants to use integrated Windows authentication. Oh, some third party, they want to use X5 certificates, right? And you end up doing a lot to support your security infrastructure. Also within your UIs, right, when the user wants to come and log in, you have to somehow collect credentials or build a login page, collect credentials, maybe do two-factor authentication. And on top of that, you might even have to do management screens, change your path, all of that nonsense. And if you build, that web app a second and a third and a fourth time, you don't want to duplicate all that code, okay? So there's a pattern that is for centralizing that sort of work. And the general token service, it's basically another piece of software that runs somewhere on the network. And the idea is that you're going to process in this centralized thing, okay? Now, the trick, of course, is somehow now the app running in one place has to somehow authenticate over to this, or trust this thing running somewhere else on the network, or, by the way, even up in the cloud, okay? Or your app may be in the cloud, and this STS thing may be on-prem, whatever. The point is these are distributed. So this is where we need to come up with security protocols to do this. So as I mentioned, there are some security protocols that have been around for a while, SAML2P and WS Federation. And then there's a newer one called OpenID Connect. And the job of these protocols is to allow a user to authenticate to the front-end web application, or the front-end application, whatever that is, whether that be the JavaScript app or the mobile app or your server-side web app. The point is you need to authenticate the user, but you need to do it from the centralized location. That's the trick. I want to get my app out of the business of managing passwords. Okay, put that in one place. So that's all well and good. And then, of course, your apps then need to invoke these APIs on behalf of the user. So there's a different protocol for that. That's called OAuth. Okay. So, which of these protocols, at least for the authentication piece, should we use? Well, what about SAML? SAML2P, you guys have probably heard of it, or WS Federation. These have been around a really long time. Why don't we just use that? I'm sure maybe some of you guys have existing apps, or especially business partner integrations, where you're probably already using this. Well, mainly the biggest problem is these protocols were designed for the prior era of application architecture. These were designed basically before web APIs. They were designed before mobile apps, before SPA apps. Okay? So these are basically the dinosaurs of the security world. So again, there's nothing wrong with SAML. It just is, out of date. And so that's basically the thing that you probably don't want to start a new project on top of. Okay? Obviously, like I said, you probably have lots of integrations that may be using these protocols, and that's totally fine. But internally within your own ecosystem, this wouldn't be my first choice. Okay? All right. What about this OAuth thing, right? I've always heard about OAuth as being how I do authentication. Well, I just mentioned a couple minutes ago on the slide that OAuth's about giving you security to a web API, and that's actually a little bit different than authentication to the front-end UI portion of your app. Okay? But wait, Microsoft says I can use Facebook to go log into my application. There's even libraries for that, or I can use Google OAuth login. Well, the problem is OAuth wasn't designed for that. OAuth was designed about protecting APIs, not providing you a way to log into an app. Although you log into an app as you use OAuth, strictly speaking, and I don't mean to be too pedantic, and I don't want to get off off the beaten path here with my talk, but fundamentally, OAuth wasn't designed for authentication. OAuth has been abused for authentication, okay? And that's actually what Facebook was doing. That's actually what Google and Twitter, they were all doing. And there are even attacks against this because they're attacking the implementation of a protocol that wasn't really designed to be doing that, okay? So the OAuth committee, the group that actually works on the RFC for OAuth, they realized people were doing this so often and so incorrectly that they even put out this white paper. And this white paper was entitled User Authentication with OAuth2. And the whole point of putting this white paper out was to try to highlight, and I don't know if you guys can read that, but it says OAuth2 is not an authentication protocol. Okay, so if anyone ever says to you again, I'm using OAuth for logins, well, I was going to say slap them or something, but don't do that. You just point them at this white paper, and they can read why OAuth is not for this. Okay? It turns out, and by the way, many of these companies still are, technically speaking, using OAuth for authentication. How can they get away with that, especially after the OAuth working group came up with this paper to say, basically, don't do that? Well, it turns out that you can add some parameters and some artifacts to the base OAuth protocol and make it secure as an authentication protocol. And then on top of that, by the way, you also get the benefit of it being a mechanism to secure your APIs. So that sounds kind of nice. It's actually kind of the best of both worlds. The problem, though, and this is still today the problem, is that the way Facebook did it is custom to Facebook. And the way Google did it is custom to Google. And the way Twitter did it is custom to Twitter, and along with the 30 or 40 other companies out there that provide OAuth logins. It's all customized. So it's not interoperable and not compatible in any way. And that's a problem. That's why you see in the Microsoft ecosystem, we have 30 different middlewares to connect to LinkedIn and Yahoo and Facebook and all of the above. So what do? Well, the OpenID committee, do you guys remember OpenID from like 10 years ago? There was like this security protocol that was trying to be used as this distributed identity system called OpenID. That as a protocol didn't really pan out, right? It just didn't get popularity. But the committee who owned that wanted to keep trying to solve that problem. And they saw how OAuth was being used for authentication, and they saw how you can sprinkle parameters on there and make it work in a secure way. So what they decided to do is say, well, we're going to go and continue our mission to provide this mechanism for doing distribution, but we're going to use our base, and we will then put on top of OAuth as the base protocol those extra parameters that I talked about to make it a valid, secure authentication protocol. But the whole point in doing this is it's standardized. Okay? So that's what OpenID Connect does, is it takes OAuth as a way to secure your APIs, with a standardization process on top of that, adds all the right parameters to turn that into an authentication protocol. And now this is the modern authentication protocol that I would highly encourage you to use for doing sign-in to your applications, distributed sign-in. So there are a whole bunch of specifications involved, but you can see at the bottom, their assumption is that they're using OAuth as sort of a base. And then there's also this other set of specifications around something called a JSON Web Token. Okay? And a JSON Web Token is a way that I can encapsulate information about my user, identity information, protect it, and then send it across the network over to you. And don't forget, we're talking about hostile networks here. I can send this information over to your application, and you can receive that and validate it to know who that user is, again, in a secure way. So that's what OpenID Connect's all about. OpenID Connect actually, in the security space, it came out in 2014, I believe, February of 2014. People have been waiting for this actually a long time because it solves a lot of problems. So as soon as it was released, there were a ton of libraries that were released like the next day because people have been working for like a year up to that, getting ready for the release of the specification. And so one of the big things about the specification, which makes it really nice, is that it was designed to be highly interoperable. One of the problems with WS Federation and SAML2P is those also were not interoperable, right? Just the same way that the Google login and the Facebook login aren't technically interoperable. So the idea is that it used to be really hard to have .NET was always, obviously Microsoft oriented, and so very much favored WS Federation. But then if you had this one Java app that somehow had to plug into your ecosystem, that became very, very problematic because Java in that ecosystem, they very much favored SAML2P. And there was just a lot of friction between the two, and it was very hard to deal with interop in there. So that's one of the huge benefits of OpenID Connect is that the spec is very much designed to be HTTP friendly and therefore highly interoperable across many different technology stacks. Right? You can have a C++ application, and I even had somebody in my workshop earlier this week who has a classic ASP application, right? That should be able to tie into this. A Java app, .NET app, you get the idea. They all can tie in and use this protocol. As part of the specification committee, what they did is they set up things called standardization tests. So if you want to build a server that provides this single sign-on implementing OpenID Connect, you can go and get certified with the OpenID Connect committee. And so there are a lot of vendors who have gone and done this. Actually, some of these are vendors, and some of these are just libraries and open source projects that you can check out. So what I'm going to do is I'm going to walk through showing you from an application perspective how you might use this and how it might fit in. And to illustrate this, I'm going to show you something called Identity Server. So Identity Server is a free open source OpenID Connect framework. And it basically allows you to take your users and your database of users and whatever your requirements are around getting them logged in, and it provides you the protocol support for that on top of your set of users. You basically run this, you set up your centralized identity server. Again, it could be in the cloud or could be on-prem, but logically it's centralized from your architecture. And then all of your applications no longer have to manage passwords and be in that business anymore. They just use OpenID Connect to communicate with your token server that you've basically built up using this framework. Identity Server is, so I said, this is open source. It is part of the .NET Foundation. So it is, has all like those legal protections. If you start using it, then you have legal protections against someone coming saying, hey, this open source project is really my IP. And like I said, it's also OpenID certified. So Identity Server, I have, you don't have to use this. But what I'm going to show you is, in terms of demos, you should be able to do with any other token server out there. So you could use Azure Active Directory instead of this. You could use Okta or Auth2 or any other, certified OpenID Connect provider, and basically get the same feel from the applications that I'm going to show you here. Okay? I happen to have a preference for Identity Server because I'm one of the co-authors of it. So, all right. So again, here's what we're trying to do. We have applications that the user is going to interact with. These could be a server-side web application, could be a SPA, could be a native app. And the idea is those are the front ends, and you want to authenticate to those front ends. So OpenID Connect supports all those different types of applications. Again, that's why it's more modern, if you will, than the older SAML2P and WSFed, because those only knew how to do server-side web apps. And the older protocols didn't know how to then also allow you to call an API on behalf of the user. So that's what we're going to do here. A couple mechanics that you kind of have to be aware of is that the protocol server, this token server that I'm talking about, supports endpoints. And that's kind of what the protocol is all about, right? The spec defines certain endpoints so that your application can interact with them in the token server to get the results that you want, right? Authentication and API access. So a couple endpoints to just be aware of. There's something called the authorized endpoint, and there's something called the token endpoint. The authorized endpoint is the endpoint that your app would send a user to in a browser. So think about what happens. Your user hits your app. By the way, in the protocols, the app is called a client. So I will frequently use that instead. And a lot of people come with the mindset that client is the customer or client is the human, and not. In the security space, client is the application, which is different than the user. So the user is using your client application. They are anonymous, and they need to somehow get logged in, or your app decides that they need to log the user in. And that's normally where your app would redirect the user to your login page. Except that's the whole point. I don't want each of my apps to have their own login page. So instead, you will redirect the user to the centralized token server, and that's what the authorized endpoint is for. So you redirect the user there, and the expectation is that the user will probably see some sort of UI at the authorization endpoint, namely a login prompt. Okay? Now, there's another endpoint in the token server called the token endpoint. And the token endpoint is meant for your client application to communicate with directly and programmatically. So in other words, you think of the token endpoint as like a RESTful API, and that's something that would be used directly. So depending on what type of app you're building and what features of the protocol you're trying to use, your app will be interacting with one or both of these endpoints. So the other thing to kind of be aware of when you're learning about the protocol is to understand these things called flows. And what a flow is it's basically a workflow, if you will, that the app must go through to get the results at once. right? It wants authentication for the user, and it wants API access on behalf of the user. And the different flows are basically just different mechanics on how you deliver results to the client application based on the nature of the client application. So in other words, if the client application is running server-side on a web app, it's going to have to communicate with the token server differently than if you're running on a native and a mobile environment, for example. Okay, so it's just mainly mechanics of the protocol. But the protocol supports these different scenarios. So we're going to talk about these as we go along. Okay. By the way, any of you guys ever read the OAuth spec? RFC 6749? No? Nobody? Oh my gosh, it's great bedtime reading. Okay? So yeah, you'll see the word flow, or grant type is another terminology for that. So yeah, if you've not read that, then, like I said, great bedtime reading. Okay, so hopefully the rest of my talk will give you a little jump start on the spec in case you don't have find time to read it. So here's the first scenario what I'm going to do. We're only going to do authentication first. So I have a server-side web application where I just want to know who the user is. And let's say, that's again centralized. That's the whole point of this architecture. When the results come back to my app, I don't need to call any APIs. Let's just say your app knows it's Bob, and then you maybe connect directly to a database, and you pass Bob's ID when you do your queries or whatever. So that's this first scenario we're going to talk about, and that uses what's called the implicit flow. Strictly speaking, let me go back to, implicit flow means your app only communicates with the authorized endpoint. There is no back channel call to the token endpoint, just again from a pedantic standpoint. So here's how this works. Your app your user uses your app, your user's anonymous. At some point the app says, hey, I need to know who the user is. So you need to redirect them to log in. Again, instead of your own login page, you're going to redirect them to the authorized endpoint. And in the authorized endpoint, one of the part of the protocol is there are parameters. And the parameters basically allow your client to express a bunch of information to the token server about this request for authentication of the user. So there's some parameters like what's your client ID, what URL do you want the results at, right? You're going to send the user over there, and then the token server has to bring them back and give you results. So that's this redirect URI. This response type parameter is how you indicate what you want back. And right now, the only thing I want back is proof of the user's identity. That's just authentication. And we do so in the protocol with this type of token called an identity token, or ID token for short. So that response type parameter basically says what I want back from the token server. Response mode form post basically says, hey, I'm running server side, so you need to deliver it to me server side. Nonce is a protocol parameter to deal with replay attacks, which is a nice feature that things like WSFed didn't have. And scope is a parameter where the client application can express what information about the user it would like. So OpenID is a scope that indicates you want the user's unique ID. That's pretty important, right? The unique ID of the user is something that never changes and is the same value every single time that user logs in. So that's actually the most important thing you care about. Okay? We actually call this the subject identifier. It is the subject is the human, and that's their identifier that the token server will produce. It looks like then we're also saying, oh, by the way, I would also like the user's email. So the scope gives you a way to have a white space delimited list of names of things that you want from the user. You can always come up with your own as well. Right? You can come up with a scope called employee info. And employee info as one label actually could mean you want the employee ID, you want the employee phone number, their cube location, the building there, whatever. It could map to 5 or 10 things. Okay? That's up to you. So what's going to happen next? Well, when the user gets sent to the token server, the user is not authenticated. So of course, they're going to be asked to log in. So the beauty about Identity Server is that you get to build this login page, and you can make it do whatever you want it to do. So if you have a legacy database, great, pop that in here. If you want to have employees log in with their AD account, then you can give the users an AD button, or even Azure Active Directory, right? You can go wire up to Azure AD as well, or let the users log in with social, Facebook or Twitter or whatever. Okay? So that's the point of Identity Server, is this kind of stuff is totally in your control. You can't always do this with some of the other paid products, and that's the main differentiator. It's actually interesting, you can actually use this with the paid products as well, like Azure AD, right? That's for example. So anyway, Identity Server gives you a nice bit of flexibility and control over how you design this. Great, so the user logs in. What happens next? Well, after this, you may or may not see this kind of page called a consent screen. The consent screen is asking the user if it's okay to release this information about them to that application. Oops, sorry again. You might have seen this kind of screen if you've ever logged in with Facebook or Google, for example. And the idea is that with Facebook and Google, you as a consumer have a relationship with them. They know lots and lots of information about you. And then they are about to release some of this information to potentially a third-party application. And if the application requesting this information about the user is third-party, then prompting the user is probably a good thing to do and say, hold on, it's asking for all this stuff about you. Do you really want to allow that or not? Okay, so you can say yes or no. If the application that you're building is your application, and the token server that you're using is your token server, and the users that are behind that login page are your database of users, then you're already within a trust boundary. So this screen is something you can just simply disable. Okay? Turn it off for that particular app. So you can enable and disable this app by application. Okay? So once consent is performed, that's like the last chance for the user to bail out. And if consent is given, then the token server must produce that thing that we talked about called an ID token. That's the identity information of the user. And the interesting thing about how it's delivered back to the server, back to your client app, is it's actually rendered into the browser as a form tag. And the action, the URL of that form, is back to your client application. It's actually the redirect URI that we saw 2 slides ago. And then it's not shown on here, but there's going to be like a little line of JavaScript that as soon as this loads into the browser, the JavaScript is going to auto-submit over to the token server. Okay? Does it feel like a hack? Absolutely. Okay? It's the web. You guys ever log into your MSDN accounts? Yeah, well, that's what's happening under the covers. Okay? It's cool to run Fiddler Trace on this. So what is this ID token? Did I already say? I forgot. Any guesses? A JSON Web Token, exactly. So this identity token is that thing called a JSON Web Token, a JOT. You call it JOT for short. They even put that in the spec, pronounced, quote, J-O-T, close quote. So the JOT is actually a couple of JSON objects that are then base64 URL encoded, or serialized, if you will. And then there's a digital signature placed on top of that information. Okay? So this JOT actually has 3 sections to it, and the 3 sections are separated by the dot. Okay? And so the first section maps to this header. This header is just metadata about the JOT itself. Basically, the big thing is that this is in fact a JOT. The signature algorithm that is being used is an RSA signature with a SHA-256 hash. That means it's an asymmetric key being used. So the server has key material, a private key, and your client, your consuming application, to validate this thing, it's going to need the key. Okay? Oh, and by the way, the KID, KID, stands for the key identifier. So your token server may have 10 keys. Which key was used for this token? Well, that's the identifier for it. Names or the payload. The payload has a combination of protocol data. Top section of the claim section has the issuer, who issued the token, the expiration, right? How long is the token good for? We don't want this thing to, want the end user to like hold on to this and then like do it again next month when they've been fired or something like that. The audience is where the token is valid. And that audience actually is the identifier of your client application. I like to use the analogy of the hotel cards here. These are all tokens. They were all issued by the same issuer. That's the front desk of the hotel. But each card has a different audience, which is the room number that you can use it at. So that's really important when you're dealing with tokens, is that you don't just want to check that it came from somebody you trust, but you also want to make sure that it's only allowed to be used at a particular location. So that's what that audience parameter value is. And that last parameter is something called the nonce that has to do with our replay detection that I mentioned earlier. So that's what your client application has to do, is receive this thing, unpack this thing, grab the metadata, validate the signature, validate the issuer, expiration, audience, and that nonce that I talked about. But once all that's done, then you can trust that the user is subject ID 182JMN, whatever that says. Okay? That's who your user is, and you get back the identity data that you asked for. Questions? Yes? You can have multiple audience. True, yes. For an ID token like this, typically that's only the one client app requesting it. But a JSON web token on its own, independent of OpenID Connect, yes, technically could have more than one audience. Usually if you have two different apps that both want the identity of the user, they each go and make their own exchange to the token server. Okay? Rather than the two apps trying to collude and share that. Because, again, that's not in the spec. Who knows if there's, if you come up with some way to pass it around, maybe you've introduced some vulnerability. We very much prefer to like to stick to what the spec says, because there are not only like 100 people working on and reading the spec as it's being developed, but then after it's been published, you have thousands of people actually implementing it, reviewing it, attacking it, doing research on it. So it's like a massive peer review, and that's why we like open standards for things like this. Okay, if somebody comes up to you and says, we have a super secret algorithm for doing sign-in, nobody knows about it, it's probably snake oil, right? Okay, other question?
If you're like internal and you're using Windows OAuth, is there a way to essentially create a token without having to?
Yes. So the question is, let me see if I understand the question, is if you're using Windows authentication internally within your network, can I basically get a token server that will then issue this token based on the Windows identity? Okay, and absolutely. So basically the way that would work is this login page would have to support integrated Windows authentication. Okay, so I can show that actually to you. So that's a good time for a demo. Oh, actually, one more thing. You can't read this, so this is an awful slide. But remember I said that the signature? We need the key material so we can validate this token. How do we go about and get that key material? Well, the token server will publish this thing called a discovery document, and the discovery document is metadata about the token server, and that metadata has things like, actually, what was the URL of authorize in the first place, and what's the key material that you need to validate this based on key ID MJ39, whatever. So that's what the discovery document is. So let me just show you this running real quick so I can show you kind of what that might look like. So this solution that I just, that's the wrong solution. This solution here is a Visual Studio project that I have that is hosting Identity Server. And again, we'll have a session later today on more details about how you might set this up. But this is the home page of the token server. And what you typically do in your app is you set up a configuration. You say, that's the base address of the token server I trust. And based on that base address, the discovery document, which is published at a well-known path relative to the base address, gives you all kinds of information. So this is actually the URL right here of that authorized endpoint. Think of it as like the login page that I need to send the user to. The other one here is this one here, JWKSURI. If I click that, look at that, key material. So this is my RSA key. The key ID is 6FA something or other. Here's the exponent. There's the modulus. Okay? So that's the discovery document. So what I'm going to do now is I'm going to run a sample client. This is another project I have Visual Studio. And this is an MVC application. And the beauty here in the MVC application is all that protocol stuff that I told you about. Yeah, you don't really have to worry too much about that. You use Microsoft security, helpers in ASP.NET Core or even Owen and Katana. If you're using Owen and Katana, there's OpenID Connect support. Basically what you do is, maybe you can see this or not, is you basically teach your app what's the base address of the thing I'm trusting. Okay? And then you configure this with things like, oh, and by the way, my client ID, that's my client ID. Here are the scopes that I want for this user. I want the user's email, their unique ID, and then this profile scope is one that maps to like 12 claims, like your display name, your first name, your last name, your gender, your location, your the URL for your picture if you have one, a bunch of stuff, okay? So I'm going to run this. And actually, while I run this, I'm going to run Fiddler, because that's always interesting to look at. Also, just see what the operating system is doing to spy on me. Okay, so here's my MVC application. They're going to look the same because they both have the same, because I'm so innovative with my UI design. They have the exact same Twitter Bootstrap theme. But the thing to look at here is that we're first running on 44077 is the MVC client, and identity server, the token server, was running on 5000. So what I'll do here is I'll click my secure link, and actually let me just show that to you real quick as well. The beauty about this is hey, we all know what that does, right? So that's what's going to happen is you're going to click that link. Your client-side plumbing will kick in and say, hey, I need you to go log in, but instead of your local login, we've gone now to the token server's login page. And this is where the server can pick whatever they want. I don't see my AD button here. I wasn't planning on showing that to you, but yeah, I'm running Express. And in here, enable Windows Auth. And then we have actually a separate flag here. So the UI that you're seeing is just what we call the Quick Start UI. It's basically Windows Auth enabled. Do you see? Oh, it's right there. It was right in front of me. I didn't even see it. So yeah, we have integrated Windows Auth enabled here if you want. Okay. So yeah, you can do this. So sorry, I got off track there. The UI you're seeing is provided by some starter code that we give you called the Quick Start. The intent, though, is you to take this and totally rip it apart and put in whatever your UI you want, whatever database you want. It's up to you, okay? But the starter one, to get you started, has a local login and some of these others, okay? So I'll click Windows. Okay, that just did an integrated Windows authentication handshake, so I didn't even enter a password because I'm logged into the domain, presumably. Here's my beautiful domain, username, password. Okay, here's the consent screen that I told you about. I'm going to hit yes. And look at that. I'm back over in my MVC app with the outcome of the authentication, which this is the thing you really care about is the user's unique ID. And it looks like the only thing else I had about the user was the user's name. Okay? So again, that's another thing is all the data about the user, you bring that. So you're going to have a database with all this stuff, and you can plug that in and load whatever you need. On the network, we sent the user to the secure link. The secure link redirected them back to the authorized endpoint. The authorized endpoint passed all these parameters I just showed you a little ago. The authorized endpoint said, oh, you're not authenticated, so I need you to log in. So it sent you to the login page. We submitted the login page with integrated authentication. We eventually then came back into the protocol endpoint, and the protocol endpoint then said, oh, I need you to do consent. So we showed the consent screen. And then we went back again, and then ultimately, I think this is the last leg in the token server. Yeah, this was the last leg in the token server, where now the token server rendered the form that I mentioned, the URL back to the MVC application, and submitted the ID token. And here's our one little line of JavaScript at the bottom that submits this. So it's kind of interesting to go look at this ID token. There's a nifty little website called jot.io that you can use to check this guy out. So I can take that JSON Web Token and paste it in here, and you notice it's got the dots in here like I had mentioned, and this tool will break it apart and parse it and say, hey, yeah, by the way, this is a JOT with RSA 265. The key is 6FA, which, does that ring a bell? 6FA? Hey, look at that, 6FA. That's the key that was used. And then here's all the protocol information, and here's my user's unique ID, and they use Windows to log in, and their name was the silly domain name. So back in your app, you receive the results, and then typically what an app does is then it validates the token and then issues its own local cookie. Okay, that's the idea. Questions? Yes? So I'm trying to understand the comment. So the comment is usually your application has its own login page? Yeah, well, so yeah, a couple things. One, you can style this login page any way you want. And the parameters that are sent by the client include the identifier of the client. So you have that available to you on that login page. But you're thinking maybe a little wrong about how this whole thing works. When you go and use your Google Calendar, do you log into the Google Calendar app? Or when you use Gmail, do you go log into the Gmail app? The answer is no. What do you really log into? You're logging into Google. Okay. Okay, all right.
Because we want to let our client feel like they have their own dedicated application.
Okay, that's a little, if you're talking about like multi-tenancy, that's totally doable, and that's a different question, and yes, that's all very possible. Yeah, exactly. So that's why I said all that UI in the token server, it's all your code. Make it do whatever you want.
So basically what he wants to know is whether can we customize the login page per application?
Can you customize the login page? You actually want to customize it per tenant if you're doing a multi-tenant scenario. Absolutely. We even have a parameter for tenancy. So yes, that's all very, very possible. It's your code. So if you design it as one page and you can figure that out, party on. Okay? Okay. When am I supposed to be done? 12:15? Really? Okay. Well, we're going to go quickly here for the rest of this. So, okay, you guys got the idea. So the last thing to quickly talk about then in the last 15 minutes is accessing APIs. So one way to access an API is from your server-side code to the API, where the API invocation is on behalf of the app, not on behalf of a user. The other scenario is you could be using, a user could be then hitting your server-side code, and you want to invoke the API on behalf of the user. So those are, logically two different scenarios. And the other two things are you could be using a SPA or a native app, and those want to hit the API, again, on behalf of the user. So those are the other scenarios where we're talking about protecting the API portion. For the scenario where you're invoking the API on behalf of the app itself, what happens is the app will go to the token server and obtain a token, and that token is what will be used to call the API. So the idea is that the client, the application, doesn't have a credential with the API, it has a credential with the token server. The API trusts the token server. Just like we just trusted it for logging a user in, the API will trust it to know who the caller. This caller here is just an application. So that application will connect to the token endpoint. Remember, this is the other endpoint token server, the programmatic one, and it will pass along what it's called its client ID and its client secret. That's how the app proves it's this app. And then it also passes along that scope parameter. Earlier was how we said what. In this scenario, scope is saying what access we need to an API. So we're saying, I want access to API. And that access token that you get back, an access token that's different than so this is the OAuth portion of those two protocols I was telling you about. So the access then you send to the API, you set it as the authorization header, and you use a scheme called bearer. Again, much like my hotel room key. Okay? This is a bearer token because whoever bears it or holds can use it. Okay? All right, that's it for app server-to-server scenarios where you don't have a. I have some demos here, but I think given the time, I'm not going to bother. Yeah, you just put authorize header on every HTTP call to the API. Of course, in the API, you have to validate that. So I'm not following that part of your question.
So when you set authorize, you have to set up the OIDC.
Yeah, okay, let me just show you the sample instead. Okay, so the idea here is that then over in our app, I now have an API here, sample API, in my startup code, okay? I am adding in the authentication plumbing, and then I'm saying, yes, support this token. Microsoft has an implementation called add JOT bearer, and you would set up the configuration to support JSON web tokens. It turns out that, and again, a little tongue-in-cheek here, that since Azure only supports JOT bearer, so Microsoft only supported JOT bearer. Remember what I said, this here is a bearer token. I have another token though, and you guys all probably do. This is a different type of token, right? So this is a different type of token. This is called a reference token, right? So there are other token formats, or this is called a holder of key token because it has my picture on it. I can't give it to you. It's not a bearer token anymore. So there are different token formats and different features of different tokens. Identity server, our token server, supports many of those. The Microsoft one doesn't. So we built our own authentication handler to support all those additional features. Our implementation in the API layer, if the token coming in is a JSON web token, we just call it the Microsoft code. And then we just add all the other features that they didn't support. And then in your client application, since I will show this to you, basically you have to have some code that goes and gets a token, right? To get the token, you can load up the discovery document I mentioned, figure out what the token endpoint is, and then use a little library to connect and ask for access to API 1. Right? So this little helper here, this token client, is another open source library that we work on, basically giving you OpenID Connect and OAuth2 protocol feature support. And this is something that's missing in .NET, basically. So we needed it, so we built it. And so once you have your token, you then call your API with that token. And all you do is use your good old HTTP client, and you set the client.default request header.authorization equals new. And for some reason, it's called an authentication header value. And you would do bearer, B-E-A-R, and then you put the, whatever your token is in here. Okay? We have an extension method that adds that one line for you. Okay, so I can just run this real quick. It should work. So the console app will go and get a token. We spew it out on the screen for you. We even are decoding it just so it's easier to look at. And then when I hit enter here, I'll actually call the API. And the API, maybe it's not running. Oh, no, there it goes. It's running. And what the API is doing then is the middleware in front of the API is validating the token, takes all of the contents of the token as claims, and makes those available into the API layer. So you just have a list of key value pairs that represents who the caller is. And that has the client ID, which is the app. If there were a human here, you would have a subject claim. In this case, we don't have a subject claim. We only have a client ID because there was no human involved. So you know it's only a server-to-server call. Okay, so then I guess we'll have time for this last one scenario. I probably won't have time to show you mobile and SPA style, but once you know the mechanics here, the rest are pretty simple. So the last one I'm going to have time to show you is the concept of taking that MVC application and now having it receive not only an ID token for authentication, but now also an access token so that the MVC application can call the API on behalf of the user. So that uses a modified flow called hybrid flow. So previously we were just using what was called implicit. Now our app has to actually interact with both the front channel token endpoint in the token server, the authorized endpoint, and the back channel, which is the token endpoint. So you have to switch your protocol a little bit and use this thing called hybrid. So again, here's our MVC app. You still send the user in the front channel to start with, but there's a little bit of change in our protocol. What we're now doing is in the scope, we're now asking for not only identity information, but now some amount of API access, again, on behalf of the user. So that's one thing that's a little bit different. And then this is the other part that's different here, which is saying where, yeah, we still want the ID token, but now we need this new thing called a code. The code is going to come back via the front channel. Okay? The code is not the access token. Okay, it's kind of weird. Well, hold on. That's all I want is the access token. Why can't it just send me back the access token in the front channel along with the ID token? It could, but the protocol is designed to minimize exposure of the vulnerable parts of this thing. And that access token, if somebody intercepts it, then that's a problem. And to be honest, is mainly the user, right? Do you want the user to be able to lift the access token and then go write their own app to hit whatever APIs you have? Maybe not, okay? If you are building a SPA where the access token ends up in the browser, that's a different story, okay? But the protocol using this thing called hybrid flow leans you towards trying to protect the access token from being exposed or leaked. So that's why we don't deliver back the access token in the front channel. We put a level of indirection in there, and it's called a code. So what happens is this code is sent back to your server-side application, and the server side, this is why it's called hybrid, because now you're going to interact with the back channel call. So your MVC client on the server, once it validates all that ID token, it then on the back channel uses the token endpoint, sends the code, and also it now has to have a secret. Because to use that code, we have to prove that it's really the MVC app that's trying to use the code for an access token. So you programmatically use the panel, you exchange the code once you've authenticated, and you get back your access token. That access token is the same access token that we saw a few minutes ago from the console app that I showed you, and that can be used to then call your API. So I have one more sample here I'll quickly show, which is MVC hybrid. I'll run this. And actually, you know what? I think I'm still logged in over here. So another interesting thing you will see is we'll get the benefit sign-on. Okay, that's another really good use of centralizing this login is that you've logged in once, all the other apps will be able to piggyback off of that. So now I'll go over here to this new app, I'll click secure, okay, and notice I didn't have to log in because I was previously signed in. This is a different consent screen because it's a different client app. Again, you can disable this. And now notice we're saying, oh, by the way, I want access to some API on your behalf. And so when we give consent, we now have given back now an access token. So let's pop this guy open real quick into jot.io just to see what we're going to see. So same thing, same key, same kind of protocol information, but what's a little different here? Yeah, that's a little different, that's different, that's different. Okay, so the idea is that now I have a user because I have a subject claim, and I know other information about the user. Okay, so I should be able to now call the API, and the API now echoes back the response. Again, the big difference is the API now knows who the user is. So that's basically invoking an API on behalf of my user. Okay, questions about that? If you're in the back, I honestly can't see much back there, so okay. If you have a question and I can't see you, come up and ask me afterwards here. I'll just briefly show you what a JavaScript app and a native app will look like. So a JavaScript app, we don't have a server side. We have an API somewhere, but that's not part of maybe your front end portion of your app. You have no back end that renders a UI. So a SPA type of application would basically say, hey, I just want the access token back directly. I don't need to do this code back channel. I don't have a server-side bit. So what happens is the way the tokens are delivered back to your SPA are actually in a GET request, not a POST, and they're delivered via the hash fragment in the URL. And that's how your JavaScript then can scrape the results, have the ID token to know who the user is, and the access token to call the API on behalf of the user. Okay, so once you know the base protocol mechanics, a SPA, not too different. There is a helper library that is also OpenID Connect certified, that's open source and free. It's up on NPM called OIDC Client, and this is a really useful library for in your SPA to do the protocol result processing. Okay, so it basically helps you out with the protocol. Kind of like the Microsoft code is helping you on the server side. Okay, there is no JavaScript client for this that I found other than this one. And the last one, native apps. So these are like your iOS, Android, but they could be a desktop WPF app. And the idea here is that those also can send the user to the token server to log in. The thing to understand is that the latest recommendation on how native apps should communicate with the token server is that you are expected to pop open a browser. That may be weird, but it actually works perfectly fine. Okay? So you pop open the browser and you send them to the same authorized endpoint I showed you before. And when the response comes back, there are, depending on what type of browser, there's an embedded browser and then there's the system browser. But depending on which of those you use, there are mechanisms for getting the results back into your native app. Yep, so I have a sample right here. This is actually a Xamarin sample. So this Xamarin sample, basically I click login, and we're using the operating system browser. So we're using something called Chrome Custom Tabs. And if I have an internet connection, yeah, look at that. It popped up in the browser. I'm now in this Chrome Custom Tab. I can log in with Bob and Bob. Okay. I'm not the best Xamarin UI developer because I think that came back. I have like Yeah, okay, there's the results. I just didn't pop the window open when I got the notification. But that browser actually went back to my app, give me my results, and I got all that stuff from the results. I have my ID token that I validated, and here at the bottom is my access token. And so if I call an API, that still works. Say again? Yeah, so these are all up in the samples. Well, you mean latest. I guess you have been following some of the... Okay, so yeah, I just actually rewrote this on the flight here a few days ago, and it's now under a folder called Android Client VS 2017. Basically, the older sample we had for VS 2015 stopped working for some reason. So, and again, I'm not a full-time Xamarin developer, so I rewrote this for 2017. But anyway, the point here is that your mobile apps, that also can work for a WPF desktop app as well, okay? Especially if you have your integrated Windows off, that'll happen and the user won't even see that. Okay, so hopefully you guys have seen how these protocols work and how your client application would be interacting and how your API would then establish trust. So, oh, by the way, here's some helper libraries for your native apps as well. If you want to build a native, we have support for Xamarin, but there's also, if you're actually doing in Swift or Java native, Google has some samples out as well up on GitHub. Okay, so some helpers for that. Okay, so other than that, more resources related to how the protocols work, and actually Identity Server and Identity Model, the helper libraries that I showed. And other than that, thanks for coming, and I hope you now understand a little bit better about OpenID Connect, and thanks.